Hello, in this video I'll show you how to start your analysis. Of course, at the previous videos we started talking about how to prep your survey data in Excel and how do you do cleaning, data cleaning, and how do you detect and correct for missing data, and how do you detect also biased responses by using the standard deviation so that you can get rid of these surveys that you collected where the person or the participant just decided to answer 1 for all the questions or 5 for all the questions. Second, in this video we're going to talk about exploratory factor analysis, EFA, with SPSS. Exploratory factor analysis is not common among researchers who are doing structural equation modeling. And the reason for that is, the way that I like to explain it is, not many researchers would like to take the risk of creating a survey that is not based on a well-founded theory. Because what you're doing is you're taking a very high risk of creating a survey and based on pieces of the literature here and there, and then putting it together to measure, for example, an intention to engage or so on. And at the end of the day, after collecting 200, 300 surveys, you're not sure if they're gonna actually give you good results or not. So basically, most of the researchers and research students, they take the safe side, which is find the theory that others have tested and used to measure or explain the variations in a certain latent variable, and then you can use what we call it confirmatory factor analysis, CFA, followed by structural equation modeling, SEM. However, if you created your survey not based on a very founded theory, but of course there is definitely a literature backing for why you have chosen to study these certain measures, but there's no solid theory that puts it all together into perspective, then definitely you have to run exploratory factor analysis. So exploratory factor analysis, you can't do it on Amos. So you need to get SPSS or the trial version of SPSS, which is available for your use for 30 days. So over here, this is the data that we collected on engagement on Facebook. And let me show you let me see if I can get very quickly. What we thought before running the analysis, what we thought that could be a valid where is the risk here? Here, a valid model. So we thought that we're gonna study the intention of an individual to engage, and we're gonna see the crowd engagement behavior effect on it, and the trust components, its effect on it, like affective trust, cognitive trust, and then the risk factors or the risk factors. So this is what we were thinking: 4 different latent variables. This variable is the latent variable that we are very much interested in studying, and this is the latent variable crowd engagement, latent variable risk factor. But in fact, also we have a latent variable as trust. In fact, we are thinking to separate the trust into affective trust and cognitive trust. So my expectation is to get 1, 2, 3, 4, 5 latent variables, or 5 different factors as a result of factor analysis. Meaning, if I feed into the system, the SPSS software, all the indicator variables that I tested. Indicator variables is basically the questions, all the questions that I asked about all these guys, all these latent variables. And here's the questions, as you can see. here 1, 2, 3, 4, 5, 1, 2, 3. I think they are 4, but I just put here temporal. You need to be consistent, by the way. And over here also we have 3 questions and so on. So we're expecting here to be 1 factor, second factor, third factor, fourth factor, and 5 factors. Okay, as a result of the factor analysis. Let's now run the factor analysis and see, are we going to get what we are expecting or not? How do we do that? Of course, you have to import your data. You can just import the data here, either as an Excel or either as a database, wherever you have it. And then once you have it here on SPSS opened, please save it. I think I saved it here as what? As data. So I saved it as data. Okay. All right. So now let's begin our analysis. If you want to start the analysis in a very nice way, I have here explained the first thing to do that I like doing, in fact, is to get a sense of the correlations. You can get the sense of correlations either separately before the analysis, or you could get it as part of the factor analysis. So if you want to just take a look at the correlations first, you can just go to Analyze and go to Correlate and then go to Pi Variant. Why do I want to go to Pi Variant? Because most of that my data is ranking data, is ordinal scale. So I need the Spearman parametric test for that. So these are all my factors, but I don't need to take, I don't want to look at all the factors. In fact, I want to look at each set of factors, or sorry, each set of indicators that's supposed to load on one factor separately. So over here, I can see somehow the correlation coefficients here. It's the Spearman's raw coefficient. It's above 0.3 here, 0.5, 0.6, and 1. So they are there's somehow correlated to one another. And let's do it again. For example, here correlate, and instead of these set of variables, let's take a look at the risk, or the risk here, or the risk. You can just hold down the shift key and click at the last element here. This is one of the good practices of doing things, that you start the name of your variable with a shortcut of the latent variable. So over here, we can see that we have over 0.2, 0.3, 0.3 over here, and so on. You can do such a thing. You can save also the output. So you can, first of all, start with a general exploratory analysis if you want, but it's not really necessary. The thing that you need to do with this data is to do a factor analysis. And you do factor analysis by heading into the analysis and then go to dimension reduction and then go to factor. All right, I've run factor analysis before here. I want to do it again. All right, so here is the factors. As you can see, I kind of skipped some of the factors. We might have to do so to get very good results. But over here, these are all the indicators that's supposed to load on risk, crowd engagement, trust effective, trust cognitive, TC, and engagement. Descriptives, initial solution, KMO and Bartlett's test, reproduced also, so that you can get the correlations, the correlation matrix and the residuals. Extractions, get the unrotated factor solution if you want, and get the scree plot, correlation matrix for principal components. And in fact, start with the eigenvalue, all right, and then continue. Rotation, most popular is the Promax and the varimax. I'm going to start with the Promax. scores, you can save the scores as variables. I don't want to do that right now, so let's let be. I'm going to keep this and as is, but over here on coefficients display, I only want absolute values to be greater than 0.3. So suppress small coefficients means don't show me coefficients below 0.3 as a threshold. So this is the loading threshold. And here's the analysis. Let's together, in this also sheet, I explain to you what is communality, what is unique variance, and what is a specific variance and error variance, and also the factor extraction, rotation, and so on. All right. So let's now talk about the results. As you can see here, first is the KMO and the Bartlett's test. What's the best practice? Best practice is over 0.8. So here I have for you, as you can see on the screen. So according to Kaiser 1975, KMO greater than 0.9 is marvelous. Between 0.8 and 0.9 is awesome. 7 and 8, 0.7 and 0.8 is middling. So this is maybe the acceptable for most researchers. They say this is and above is the acceptable. This is mediocre and this is miserable and this is unacceptable whatsoever. So some researchers maybe say it is above 0.5 is all right, but I would say above 0.7 may be acceptable. The higher the better. 0.8 and above is good. This is awesome. So let's take a look at our results here. Our results indicate 0.79, almost 0.8, so that's good. And is it significant? Yes, it's significant. 0.001. Right. Criminalities, these are the variances. With the criminalities, here's an explanation, a decent explanation of criminalities. Guys, have it already for you here. And a common threshold here is to be above 0.3, but if 0.4 and above is good, here I have 0.3. Hopefully I won't have anything below 0.3. I haven't. Some resources embraces the 0.4 as a threshold and so on. Let's talk about the total variance explained now. The total variance explained, we just want to make sure that the variance, the cumulative total percentage of the variance is not loaded super high right on the first factor. The higher the better, of course. So the cumulative all the way, actually before the cumulative percentage, let's take a look here. Over here, the analysis indicates that I have 1, 2, 3, 4 components. However, just before we started, we were talking about 1, 2, 3, 4, 5. So, well, I am wrong. Apparently, we have 1, 2, 3, 4, and they all together responsible for explaining 56.18% of the variance. Let's go ahead and see what are these 4 components. This is the scree plot. So here you can see that 1, 2, 3, 4. After that, well, there isn't much to explain here. This is the component matrix. Let's skip to the reproduced calculations. Reproduced calculations has 2 parts. The first one is the correlations. So this is here the correlations, and here is the residuals. I'm going to copy that and take it to Excel. Here at Excel, as you can see, I am very much concerned with the residuals. So I'm going to just select the residuals over here. So I'm going to select the first cell, hold down the Control and Shift keys with my thumb and my index fingers respectively. Use the arrow key to move to the right. Use the down key to cover all this area. Then go to conditional formatting and color, more rules, and format only cells that contain values greater than or equal to actually, I want the errors to be less than 0.5 in some sources, but ideally 0.05. So I'm going to just start with the 0.05 first. So these values are above 0.05, as you can see, these errors. So based on whatever, this is something that you is concerning, that you have some errors here, but depending on which researcher you would like to follow their school of thought, then you could probably also take a look at the 0.5 then. Shall we take a look at the 0.5 then? Yeah, let's do that, because if there's any greater values, then that would be a problem. Yeah. Okay. Oh, what happened? Okay. I think first of all I need to clear all rules. And then I have to do it again. Sorry guys. Okay. Okay, very good. There isn't any error that is greater than 0.5. Okay, so next is the pattern matrix. This is the most important part of our analysis, and this is where things could go massively wrong. Let's take a look at that. Oh, this is, first of all, let's take a look at the first few indicators here. The order risk 1, 2, 3, 4, all loading at factor number 4. However, there is here factor number 4 also involves the cognitive trust. No, this is a crowd engagement. So it involves also crowd engagement here for negative comments. So it seems like negative comments is kind of like risk factor. So maybe this makes sense, yeah, that the negative comments on a post also indicates a risk or exhibits certain risk. Also, with effective trust, what we thought is effective trust, the Facebook friend that is not trusted or or distant in the relationship, you have the 0.371 loading on the factor number 4, which is supposedly about risk. Now, over here, the crowd engagement, we thought crowd engagement is a standalone factor, but actually, we just found out that the analysis is showing that crowd engagement and effective trust, which is the influencer effect on us, or the Facebook friend, trusted Facebook friends effect on us, also load in the same factor, which does make sense, isn't it? In fact, this is about the influence, a trust that happens through individuals, so it's effective. So yeah, I can see that we may be mistaken. This shouldn't be a standalone factor, the crowd engagement, because crowd engagement's influence on us and our Facebook friends' influence on us can both be studied under effective trust. So having this said, I am going to think about putting all these 1, 2, and these all together under effective trust. Yeah? Now about the negative comments, I probably either decide to load it with the order risk, put it as part of the order risk, and the non-trusted Facebook friend, or because it's gonna be very difficult for me to find a supportive literature or find myself very distracted here, I'm gonna maybe make a very difficult decision of dropping these factors. So over here, all the loadings are above 0.7, almost 0.6, here over 0.6. Ideally, they should be above 0.7. But above 0.5 is okay. In fact, the suppression, we asked for a minimum of 0.3. So if the threshold you're using is 0.3, then that's fine. If your threshold you asked for 0.4, then this here will not load anywhere. So it's going to be useless. Let me show you. Let's try dimension reduction factor, and on the options put it as 0.4 and hit OK. And you can see that indeed here this factor did not load anywhere. This factor did not load anywhere. Okay, how about I try a different method? First thing you need to do, other than giving up, is to try a different method of rotation. The second very popular method is varimax. The varimax method may be gonna give me what I want, what I think I should get. Here's the rotated component matrix. It doesn't have a pattern matrix, so you're gonna just look at the rotated component matrix. Again, these are very nicely loaded, and the same problem again, but however I got higher loadings here. So usually guys, we use the different rotations. Maybe we're gonna get higher loadings. This is if you have very low loadings or you have higher standards like 0.4 as the lowest loading. So as you can see, with the varimax rotation, I was able to get higher loading for the not trusted Facebook friend. So you can include it into analysis. But actually, my problem is not with the loading as a value, with the loading value, but with where it is loaded on. It's loaded on factor number 4, and I don't think this is makes sense. So in terms of phase validity, we call it. Phase validity is that are all these variables together represents or manifest one theme. I think this is yes, based on the literature, but this, I don't think this is manifesting the same theme. Try different kinds of rotations, if you want. Or before giving up, you could also try not to get the eigenvalue and say, I want the number of factors to be 5, because based on what we are thinking here is 1, 2, 3, 4, 5. So let's see what happens if we set up the number of factors being 5. What's going to happen? Are we going to get what we want or not? So over here, we're going to go to the rotated component. Over here, this factor is good, the risk. Again, these factors are loading together. So this is an extra evidence that these should be grouped together. And however, these factors did not group with the risk components. And this is also an extra evidence that I don't have to go back into the literature and dig deeper to find out how I can relate this or this to this. All right? All right. So what's the verdict here? I am going to go to analyze, dimension reduction, and for descriptive, keep as is, reproduced. Extraction, I'm gonna use the eigenvalue greater than 1. Rotation, Promax, like before, kappa 4. And well, negative, I'm gonna get rid of. And the other one that was giving us trouble is the effective trust for not a trusted friend. And then the year is okay. So this is the theoretical, the adjusted theoretical framework that I would be using. I'm going to be using this one. Let's start with the reverse order. So this is the pattern matrix here. This is loading nicely on order risk. Loading nicely together. All of them are over 0.5. Now, over here, I can, I will use this as a factor, all these together as effective trust, all these together as cognitive trust, all these together as engagement, and all these together as order risk. And this would be here, factor 1 is order, factor 1 will be effective trust. So factor 4 will be risk order or order risk. Factor 4 will be order risk. Factor 1 will be effective trust. Factor 2 will be engagement, and factor 3 will be the cognitive trust. Now for testing validity of the model, so this is it for it. I'm going to save this. So we're going to put file save, and I'm going to call it the principal factor analysis output and save it. Now next is the validity. You test for the validity by going to analyze and then going to scale and go to reliability analysis. With reliability analysis, you're going to be patient because you're going to have to take all the set of variables here that loaded over here together and find out their Cronbach alpha. So you're going to have to take, let's start with factor. Okay, I'm going to start with factor 2 with likes, share, comments, and follow over here. So ideally I should get a Cronbach alpha over 0.8. Over here it's very close, so I'm going to just consider it sufficient. Now let's put these back. This is cognitive trust. Reliability also here above 7. Analyze, scale, reliability here. This is cognitive. Then let's talk about effective trust. With effective trust, we're going to take these two. Hold down the control key so that we can select these together. Remember, we got rid of the negative comments and the non-trusted. So these have 0.8, very good. And last one would be, order risk. I'm just holding down the shift key and clicking the last element here. Oh, that is real bad. So the order risk over here had 0.67, almost 0.7, not very high reliability for the order risk. So you need to read a little bit and see what you could do to enhance it. Sometimes you could do nothing. So this is a different story also altogether. So this is the reliability. Usually, ideally, the loadings, all the loadings should be over 0.7 in your model, over here. If not, at least 0.5. Then you need to say, are they distinct? Yes, in my model they are distinct, as you can see. I can draw them. None of them loads on both factors, on more than one factor, meaning there's no secondary loadings, like one loading and then it's first loading and then secondary loading. There isn't any of that. And then also the face validity has to do with the theme. Do they actually make sense for you as a human being? These are all order risk. Yes, based on the literature they are. Do you think that the crowd engagement and the influencer or the Facebook engagement also altogether can be under the umbrella of affective trust? Yes. This is cognitive trust as in the literature, and this is the engagement as in the literature. Then we have to assess Cronbach alpha. We've done that. Basically, you need it ideally to be over 0.7. In our case, unfortunately, there was 0.67. It's almost nearby 0.7, so maybe we could just let go with that. So this is the principal factor analysis or exploratory factor analysis. Usually researchers don't start with their exploratory factor analysis if they have this model that I showed you earlier based on a solid theory. In our case, we just reviewed the literature and we decided to study these variables. Now, of course, if you're studying the literature and you're talking about the intention to act or the intention to behave, usually attitude is one very important variable. Attitude is one very important variable. There are very solid theories that I think one of the theories that you could use is the theory of reasoned action, for example, where the theory of reasoned action, let me show you a little bit so that you can better understand here. Theory of reasoned action. Let me show you, for example, here. Actually, the theory of reasoned action is not the latest. There is the theory of reasoned action, and there's another theory of planned behavior. Yeah, so the theory of reasoned action, there's a stronger one, which is the theory of planned behavior. So if this is the intention to behave and then you behave, there is the attitude toward the behavior, there's the subjective norm, and there's the perceived behavior. And based on this, you can study an intention to act. So this is the theory of planned behavior. Yeah, so here's the intention to act, or here's the behavior. So you have the attitude, the subjective norm, and then the perceived behavioral control. In our case, we're not using this theory, we're using our literature review in a different direction. And then we are setting up this model, but now we have to modify it based on what we just found out, or based on the output or outcome of our exploratory factor analysis. So this is it for exploratory factor analysis. In the next video, I expect to take you through to confirmatory factor analysis and structural equation modeling. Thank you.